Hey, how's it going? This is Rob Showalter. I am celebrating the Wednesday Whiteout Wednesday here as I'm recording this, but you're getting this on the Thursday. While you're doing this, your job is to use this video to help you take some notes and learn how to do the problems and then apply it on your homework. Let's get this party started. Okay, we're going to go and we're going to skip a few things since I'm not here, and we're going to look at this stuff. Essentially, we are going to expand on our conversation yesterday about graphing linear equations, and we are going to move on to graphing systems of linear equations. When we talk about graphing systems of equations, we're actually talking about graphing two lines on the same coordinate grid system, meaning more than one thing working together. In this case, we're talking about linear equations and lines. We are solving these systems by graphing. So in order to do that, we need to graph. And we talked a little bit about yesterday, and the solution to the system ends up being where they cross and intersect. So we are going to find that spot if it exists, or maybe we have an infinite amount of them that exist, and that's what we're going to find. Or maybe it doesn't exist at all, and they're parallel. Check it out. Look at this picture. This graph has one solution on this picture. Why? Because there's only one spot where it crosses. Whereas this one, this is like two lines laying on top of each other. And we call that infinitely many solutions, meaning infinitely many amount of ordered pairs work as solutions to the system, both equations at the same time. Look at this last one. These are two parallel lines, and they do not cross, which means there is no solution. No solution there, meaning they don't cross. They do not intersect. There is no x and y pair that works for both of them. Okay, let's get into what this means in terms of applying. Look at these two equations. We've got these two. Y, we're going to graph these two things separately. So we're going to graph y equals -2. So we put a dot at y equals -2. We put another dot in another spot where y equals -2. And we draw a line between those two dots, and we notice it's a horizontal line where the y coordinate is -2, no matter where you are at on that line. For the second one, might be a little bit tricky for you to graph as it sits. So let's solve this for y and get it into y equals mx plus b form or slope-intercept form. So we're going to minus 3x from both sides, and we get negative y equals -3x minus 1. We're going to continue to solve this by dividing by -1, and we get y equals 3x plus 1. And that is what we're going to graph. We're going to do it in green so we see the difference easily. So we put 1, a dot at 1 being the y-intercept. And from there, we go up through right 1, up through right 1, up through right 1. We can also reverse that and go the opposite way, and we can go down 3 left 1, down 3 left 1 if we so choose. And check it out. It shows up on a really nice spot where they intersect. Oh my gosh, look at that. That's so wonderful. So we're going to find where we're going to draw a nice straight line using the ruler. We're going to find where that intersects. And that, my friends, that is what we're going to call the solution. So we read that point. It is -1, -2 as our solution to this system. That is the point where the two graphs intersect. How many solutions are there for this system? There is one. What is that solution? -1, -2. Let's go. We've got a question number 2. Here we go. We've got x equals 2. On x equals 2, we're going to graph that one. So how do? We put a dot at x equals 2. We put another dot at x equals 2, and we connect those dots. Oh, public service announcement coming. Public service announcement coming. I'm talking really fast. You should probably pause it to catch up on your writing and rewind it, or slow the speed down to make me sound different. All right, here we go. Let's get back into it. So we graph that first line. At x is -2. It's a vertical line. Let's graph that second line here. To do that, let's first solve it for y and go ahead and graph it. So we get y equals -2x plus 1. And we're going to put our dot at 1 being the y-intercept, and then -2 being our slope. So we go down to right 1, down to right 1. We connect those dots. And with our ruler, very nice, very nice. But we notice that it crosses at a very nice point. It is 2, 3. That is our solution, and we have one solution for it, and that solution, meaning the ordered pair that is on both of those lines at the same time, is 2, -3. Woohoo! All right, let's look at number 3. Number 3 is a little bit more of a challenge because none of those are solved for, and it might be a little tricky for you to grab them without that. So let's dig in and solve these puppies for y. So we're going to minus 3x on both sides. We get 2y equals -3x plus 6. Then we're going to divide by 2 on both sides. We get y equals -3 half x plus 3. Public service announcement. Please pause it to catch up if I'm talking too fast, or slow down the video using the settings in the YouTubes. Very good. Let's continue. Now we're going to graph it. We have our y-intercept of 3. Put that dot there. We're going to use our slope of -3 over 2. So we're going to go down 3, right 2, down 3, right 2, down 3, right 2. Fantastic. And we're going to draw that line here, right here. Wow, that is so much fun having. Draw that line right there. Now, here we go. Let's look at the second one. Minus 3x minus 3x. We get 2y equals -3x minus 4. Divide by 2, divide by 2. And we get y equals -3 halves x plus, we divide by 2. So it's -2. And that's the thing we're going to use to graph it. So let's go down to the y-intercept of -2. And that has a slope of -3 over 2. So we're going to go down 3, right 2, down 3, right 2, down 3, right 2, 3, left 2. And we're going to use our ruler to draw a straight line. And check it out. Oh my gosh, look at that. The slopes are the same. They don't cross. They're parallel lines. So what do we say when that's the case? We say no solution. Number of solutions, none. Solution, no solution. Cool. Let's deal with numero 4 up in the house. All right, here we go, friends. We've got two more problems to crank it out before we get to that homework today. Here we go, number 4. We've got a situation where we got to get them y equals so it's easier to graph. You know, unless you're super fancy and can graph it super fancy like my outfit on Wet Out Wednesday. Here we go. Let's on the first one, it's not solved for y, so let's do that. So we're going to divide by 2, and we get some y equals. -4 divided by 2 is -2x. 4 divided by 2 is 2. And we're going to graph that. We have a y-intercept of 2. Boop. Put the dot there. Fantastic. Down 2, right 1. Down 2, right 1. Down 2, right 1. And we're going to drop our ruler up in the house. So we're going to draw that line. Cool. There's our black line we just drew. Now let's do the second one. We're going to do it in green. Oh my gosh. Take a look at that. It looks like it's the same exact point, which is totally weird, but also exciting. What happens is when we graph those two equations, they go right up on top of each other. When that's the case, we have infinitely many solutions on it. And the solutions to the graph are any point that is on either of those lines, which means there's a ton of points we can use. So what the solutions, I'm just going to say many or infinitely many on that, and that's kind of where we're at with it. So those are the basic ones. Then we got a little bit of a twist when we have some words around it. We just kind of dig in and see what happens. So again, we're looking at a system of two equations, and then we're going to graph and try to solve the answer for it. So, public service announcement, public service announcement. If I'm talking fast, too fast for you to record, please pause the video and think about what you're actually doing instead of just copying down the answers. All right, we're back here. Back to the regularly scheduled program. Okay, so a number, 2 times a number plus 3 times another number is 27. So we need to convert that into symbols. So we have 2 variables we're going to use. We're going to rock an x and a y, and that's just going to be, we're going to say x is the first number, and y is the second number. We're just going to, name them something. So here we go. 2 times 2, that's times, okay, 2 dot or times a number, we call that x, plus, word plus 3 times another number, We're going to call that y. So 3 times y equals 27. That becomes our first equation we're going to use. We're going to go back to the wording in the program. The difference, remember, difference is subtraction of two numbers is 1. So subtract the two numbers. The difference of the two numbers, that's the subtraction, is 1 means equal 1. And that comes from that second sentence. So now we have our two equations, and we have two variables. We're going to graph those babies, and we're going to see where they intersect if they do, and call that our solution. And that'll actually give us our two numbers that we'd like. So going back to the green line here, so in order to graph it, we're going to solve it for y plus 27, divide by 3, divide by 3. So we get y equals negative 2/3 x, negative 2 divided by 3, and then 27 divided by 3 is going to be 9. So we're going to use that to graph our green line. So we're going to start at positive 9, then we're going to go down by 2, right 2, the 3, down 2, right 3, down 2, right 3, and we're going to use our ruler to finish up the graph of that. Boop, line. Boop. There we go, and we can continue our slope if we want, just like we talked about yesterday. Okay, now for our black line here, so we're going to minus x from both sides so that we can solve it for y. We're going to divide by negative 1. So we get y equals x minus 1, and that's what we're going to graph. So we're going to start at our y-intercept of negative 1, and then we're going to use our slope 1 over 1. So up 1, right 1, up 1, right 1, and we'll keep going with that slope until we kind of, get a nice spot where they intersect. And remember, the solution, or the x and y pair that answers the question, is where they cross. So right here, our ordered pair on that is going to be 6, 5. That's going to be our ordered pair. Now it says write a system to fit the two numbers. We did. What are the two numbers? We would say, since we said the first number was x, so the first number in this case is 6, and the second number is 5. And there we go. Okay, remember, if I talk too fast, pause it, slow it down, rewind it, do all that type of good stuff so you can get the notes copied down well, so that you understand what I actually did. If you need to slow down my speak, do it to allow you to understand it. Okay, friends? All right, peace. I will see you on Friday.